All right. Welcome back, class. I know I told you I'd get this done by this afternoon, but it just didn't happen. But I did get it done before the end of the day today on Friday. And frankly, it's kind of nice to be home in my house, having a nice glass of wine, listening to some jazz music, and teaching augmented reality. So anyway, this is what we're going to be building today. So we almost got there in class. It's actually not that far off. I did figure out the one thing that didn't quite work on those of you who were able to completely follow along with me. It still didn't work at the end of the class. That was a one-line thing that we just need to fix. But then after that, we should get this, and by the end of the session, we will by the end of this online lesson, you should be able to have this indicator, and not only that, but have it change its orientation so that it's always pointing up, no matter which way your iPad or iPhone is facing, or your Android device. And then tapping on the screen will instantiate a moon object, and tapping on the moon will cause it to rotate. And we can still put another moon if we want and make that one rotate as well. So, and tapping on it again will stop it rotating. So let's get to it. All right, so let me close this app on my iPad. Great. All right, so the first thing we need to do is fix the one line that we didn't get in there from class. So if you go back into your script, and you can do that either from going into Visual Studio and opening up recent files, or you can click on it from your AR session origin down here, AR tap controller script. Double click that, and it should load it into what is this? Visual Studio. And we want to add one thing. So we created this private void method here called update placement indicator, and this is what was actually supposed to move that placement indicator around, but we never actually called it in our. We created this function, this method here, but we never called it in our update. So that was all we had to do there, was put the line update placement indicator, open close parenthesis, semicolon, and that will fix the issue with the placement indicator not hitting the floor plane. So save that, go back into your Unity project. Okay, and then I went ahead, if you want to, you can build right now and then come back. But I already built this, and I decided that the placement indicator and the moon model looked a little small to be pleasant. It was just a little bit too small. So I decided to make it bigger. So under placement indicator, now first of all, you'll see here that this has a full size of 1 meter by 1 meter by 1 meter, but that is that parent object that doesn't have any size. If you look at the child inside of it, we set that to have 0.1 by 0.1 by 0.1. Change that to 0.5 by 0.5 by 0.5. Much bigger. You can zoom out a little bit with your camera if you want. Okay, and then also go into your prefabs and load the moon. You know, it's not in your scene because we instantiate it with the tap, but you can access its parameters by going into prefabs folder and double clicking, and that brings you here. And this had the same thing where it's size 1 by 1 by 1. But if you look at the sphere inside, it's size 0.1 by 0.1 by 0.1. So change that also to 0.5, 0.5 by 0.5, whoops, by 0.5 by 0.5. Whoa, zoom back out, there we go. And then also now it's kind of mostly buried under the ground because we were only offsetting it by 0.05. We want to change that to offsetting it by 0.25. So then it should sit on the ground because its parent object here puts a registration position at the ground plane. Okay. So yeah, if you want to build this, go ahead. We still haven't added any of the functionality. Actually, let's go ahead and do that. Actually, so go back into your scene. You can click here on scenes to get out of your prefab, and let's build this. So file. I'm going to make sure am I still set for iOS? I am. I'm going to say build, and I'm going to call it iOS. And I'm just going to replace this. Will take about a minute. Oops, dropped my power source. Okay, and here's my I have two different ones. Which one is which? This one. What's this one? Oh, they're the same thing. Great. Okay, so I want to open the Xcode project. Okay, and make sure that your device is highlighted here under device, and then click on the upper level Unity iPhone object, and then make sure your team is set to your name in the signing, and hit play to deploy it to your device. And this will take another minute. I'll go ahead and start to get QuickTime ready so I can show you what I'm seeing. Okay, and here we go. Guess I should wait till it actually launches it. All right, here we go. QuickTime, cancel, new movie. Okay. All right, so you notice I put a lamp on the floor, and that's because, ooh, geez. That's because when you get noise in your camera, then it has trouble tracking the feature points. So it's best to do AR stuff with a bright light. and I can't get it that bright in my room, in my house right now, so I just put the lamp close to the floor. All right, so anyway, you'll notice that as I turn my iPad around, the logo is still facing the direction that it was facing when we first launched the app. And we're going to write a little bit of code to change that so that it's always facing, whoops, there we go, so that it's always facing the top of the screen. Okay, so let's do that. Yeah, go away. Okay, so go back into your Visual Studio, and we're gonna create a vector. Basically, we're gonna put in some code here that is, we're gonna create a custom vector that describes the forward-looking bearing instead of like just having the placement indicator at a particular bearing when you launch and it's staying that way. We're going to define the camera, the bearing by the camera. Geez Louise, I'm getting 10 emails at once. We're going to define the bearing by the camera's position, but ignore the pitch so that we just get a flat direction. Get out of there, cat. Cat is sticking his head into the lamp. All right, so to do that, we're going to add some code to the update placement pose function. So after hits.pose, put this code. So first we're going to create a variable called camera forward, and that's going to equal camera dot current dot transform dot forward, and these are all like pre-built functions. This is talking about the current camera that we're looking at. We're looking at its transform coordinates, which includes its position and its rotation, and then we're using the forward vector from that. Okay, so that's camera forward. And then we're going to create another variable called camera bearing, and this is going to equal a new vector 3 because we're creating this custom vector. And vector 3 is composed of 3 different components, the x, the y, and the z. And we're going to use camera forward as the x, comma 0 as the y, because we want the thing to stay flat. We don't want it to pitch up and down. And camera forward dot z. Oh, I forgot this. Sorry, go back. Camera forward dot x. There we go. Camera forward dot z. Close parentheses, and then say dot normalized, which normalizes these values. Instead of having them specific for the camera's position, we are getting a value between 0 and 1. Okay. Now we're going to say placement pose, which is the pose that we're using for the placement indicator, dot rotation, because we're setting this placement indicator's rotation value, equals quaternion, which is a way to describe describe rotations, dot look rotation camera bearing, which is that variable that we just defined. Okay, and there. Okay, so that should make the placement indicator turn to always face the forward direction of the camera. In other words, kind of toward the top of the screen. All right, should we build again? All right, I'm going to let you guys build again if you'd like, and then come back to this video, but I'm just going to continue on now just to save time in the video. And we're going to go ahead and add the code to place the moon on our tap. So first thing we need to do is add a public game object up at the top. So we have placement indicator, which we dragged our placement indicator object from our hierarchy into it. We're going to do the same thing with that prefab here. So we need to create another public game object and call this object to place. Object to place. Okay. And now we're going to add an if statement to our update. And this if statement is going to determine whether we've tapped the screen or not. And if we have tapped the screen, then it's going to instantiate the object to place, game object. Okay, so to do that, we're going to put an if statement. If, open parenthesis, placement pose is valid. Right? Because we want to make sure that we have a valid placement pose before we instantiate this object. And, which when you do if statements and you want an and, it's always two ands. Input dot touch count is greater than 0, which means you've touched the screen with more than 0 fingers. In other words, you've touched the screen with at least 1 finger. And so placement pose is valid. You've touched the screen with more than 0 fingers, and your input. Whoops! Go back. I spelled input wrong. Input dot get touch open parentheses 0. So this is talking about the first finger that it receives. Dot phase equals touch phase dot began. Okay, that's quite a mouthful. But what that is, and now we need to put our brackets. And that gets rid of that error. Okay, so what this is, this if statement, which is pretty beefy, but what it means is if the placement pose is valid, we're going to look for touches. And touches, so a touch count greater than 0. So if this is true and this is true, then we want to get the touch phase of the first finger, and that needs to equal touch phase began, meaning you just touched the glass for the first time. So that it'll place the object right when you first touch it. And so if all of that is true, we're going to place object. So let's go ahead and write a reference to place object, even though we don't have it yet. Okay, so place object. And it's a red line because we haven't defined it yet, but let's go ahead and define it. So down here underneath update placement indicator, but before the very final bracket, we're going to have another private void. And we're going to call this place object. Open close parenthesis. Semicolon? No, semicolon. There we go. Put our brackets, and now it's really just one line. Instantiate, open parenthesis, object to place, right? That's our reference to that game object up at the top, which will be the moon when we plug that in there. Placement pose. Where is it? Oh, well, I'll just start typing it. Placement pose. There it is. Okay. Dot position, comma, placement pose dot rotation, semicolon. So what does this mean? This is instantiating an object, and this function instantiate requires three what do you call these, parameters. First, you need to say what you're instantiating, which is going to be this object to place that we define by dragging the moon into that when we back in the editor. Then we need to instantiate it at a particular position with a particular rotation. And so that this placement pose dot position is the next parameter, and placement pose dot rotation is the next parameter. And these are the dot position and the dot rotation are components of that placement pose variable, because the pose is composed of those components. We defined the pose. Where did we define the pose? Placement pose. There we go. The hits dot pose. So like wherever we hit the plane using the ARRaycastManager, right? That creates a list of hits, and those hits, inside those hits are various poses where it hit a plane. In this case, hits.pose got populated to placement pose, and that was translated down here, and we extracted the position and the rotation from that pose to instantiate the object. Yeah, so that should work for just spawning a moon. Let's go ahead and save and deploy that. We'll take a look at that. So go back into Unity after saving that. And now if I click on AR Session Origin, you'll notice there's a new field here called Object to Place, and it has none in it. You'll need to go into your prefabs and drag the moon into the object to place. That way it places the moon when you tap. Okay, so save that, and let's build. All right, this will take another minute. Don't crash. is. Open that in Unity. Make sure my iPhone's turned on. Okay, that's selected. Click on this, change my signing, and deploy. This will take another minute. All right, here we go. I'll show you guys what I got. Get off the screen. All right, so I find it likes to latch on when you move the thing forward and backward. That's when it likes to latch really easily. But now, as you can see, I can turn the screen and more or less, it's not perfect. Uh-oh, lost connection. I don't care. Leave me alone. Go back. There we go. More or less, that thing stays with the upward position. It's not like perfect, but it's a lot better. And tapping now spawns the moon. And tapping again spawns another moon, and I can have a bunch of different moons. I can put a moon over by my cat. Say hello, Loki. Meow, meow. Loki. Hello. Moon on your face. All right. Okay, cool. So now we just need to, that's cool. That works. We can launch moon, we can instantiate moons on taps. Now we just need to add the code to animate those moons. So first, if we want to animate the moons, first we need to make a script that actually animates the moon. We're going to make a script that spins the moon around, and then we're going to control that script with a public void method that we can externally access from our tap controller script. And this is a common way to do things, and it's really an essential way to structure your Unity programming, especially when you have complex games and AR applications. So this idea of one script calling a function inside of another script, that once you get the hang of it, it will make organizing and controlling your functions and game objects much more intuitive, and you'll be able to have really complex games with lots of different things without having a ridiculously complicated C# script, because you'll just have a lot of smaller C# scripts that call each other. Okay, so let's create that C# script. So go back into your scripts folder in your assets here, go to scripts, and we're going to make a new script. Create C# script, and call this, before you click off of it, call it rotate object. Okay, rotate object. Now double click on that, open it up in Visual Studio, and we're going to use a fairly simple script here that will rotate the object with a transform.rotate function. So first thing we need to do is we're going to control this with a bool, a public bool. So before the void start, we want to put a public bool. We'll call that rotate. And you can say equals false, although you don't really need to because that's implied. And we can have a public float. This is so that you could, if you wanted to, change these values in the inspector. And call this speed equals, say, 50.0 f. And that's a way of formatting your number so that it's treated as a float. Okay. Then we have the void start. We're not going to put anything in that. And in the void update, we are going to put this. We're going to use that bool first of all. Whoops. There we go. If rotate, so if rotate is true, then curly bracket transform dot rotate. All right. Now this method of transform.rotate, this takes, as you can see, vector 3 Euler angles. So let's create a vector 3 dot up, and this means it's going to rotate around the up vector, meaning the pole of the sphere. You know, if we had said vector 3 dot forward, it would rotate, you know, on its side like it was rolling. But we want it to rotate around the pole, so we're saying vector 3 dot up. Then we, whoops, not comma, we actually say times speed times time dot delta time. And parenthesis and semicolon. And then what that will do is every update, it's going to rotate it by around the vector 3 up direction by the float that we've defined here, and have that change every time that there's a delta change in the variable time. And this is what gets time information from Unity. So if that bool is true, it'll start rotating. Okay? Then we can be out of the void update, and we're going to create another void function, but this one we're going to call from a different script, so it needs to be a public void. Public void, and we're going to call this one toggle rotate. And open close parenthesis because it's a method, and new line, squiggly brackets, new line. And all we're going to do is when you call this void function, all you're going to do is you're going to flip the bool called rotate. So we're going to say rotate equals not rotate, semicolon. Huh? What's this? What does this mean? Rotate equals not rotate. All that means is whatever you have, whatever value you have stored in rotate, set it to the opposite value. So meaning when you tap it, it'll start rotating. If you tap it again, it'll stop rotating. Okay, and that's all we need for that. So save that. Okay, go back into your Unity editor and go to your prefabs and Moon. Find the Moon, double click on that. Okay, so to activate this, we're going to use raycasting. And we're going to raycast and detect hits on colliders, because that's the way physics raycasting works. This is different than the ARRaycastManager, which detects AR trackable planes, or AR trackables. This detects colliders in game objects. And so we need to attach this to something that has a collider. So we don't want to attach it to the parent Moon object because it doesn't have a collider. There's nothing here, as you can see. But Sphere, the child object, has a sphere collider. So this is where you want to put this script. And that was something that I learned the hard way after about an hour and a half of pulling my hair out. Okay, so scripts, grab your rotate object and attach it to the sphere, and it should stick it down here. Now, if you wanted to instantiate this with it rotating off the bat, you could go ahead and check that now. If you wanted to change the speed, you could change it here. I'm going to leave it off, and I'm going to leave the speed at 50 for now. Okay, and that's all we need to do with that. We can get out of that by either clicking up here or clicking over here on scenes. Go back to our scene. And now we need to go back into our tap controller code. So I have both of them open now in my Visual Studio. And now we're going to add the raycasting code. So let's see. We're going to slightly alter the part where we start talking about touch detection. So that is, where is that? That is not here. It's up here under update. Okay, so we say, yeah, right here, if placement post is valid and you've gotten a touch and the touch began and all that stuff. Before this, we are going to now, because this was just looking for a touch, didn't care where it was on the screen. Now we do care about where it was on the screen because we need to decide whether, by using a raycast, we're going to decide whether it hit another object. So we need to actually populate a touch game object that holds the data about where you touched. And we'll just call that touch. And let's call that touch. Okay, so we've defined this object called touch, or of type touch, and we're calling it touch. And we're going to populate that with data from input dot get touch. No, get touch. Okay, open parentheses 0, first touch that it detects. Okay, so now that data will be put into the touch called touch. And we're going to look at the phase component of that. If touch dot phase equals touch phase began. See, this is the same thing we're doing down here. So basically execute this code when you first touch it. Then squiggly brackets. Okay. Now we're going to do some raycasting. To do raycasting, we need to first define a ray object. Ray, and just like we called the other touch object touch, we're going to call the ray object ray. Ray equals, and you have to tell it, raycasts go from a camera to a position. And we're going to define that by camera dot main, just like we used before, dot screen point to ray And so that will basically draw a straight line from a point on the screen to infinity and see if it hits any physics collider objects. Okay, and then you need a position on the screen to cast that ray from, and we're going to use the touch dot position. Okay. All right. Now we've defined that ray. Now we're going to use another object type called ARRaycastHit. And we're going to call that hit. And we're going to use another if statement. If physics.raycast, and then open parentheses, and then you have to talk about you have to specify what ray you're talking about. Ray is what we called it, right? Raycast ray. So if physics raycast ray hits something, then output out a list of objects that it's hit, and we're going to call that list. We're just going to call that hit. Okay, and this is the common way to code this. You could change this to hit object or something else, but on Google, most of the different, when people are using raycast examples, it's usually this function. It's ray, screencast hit, or raycast hit, and physics.raycast ray out hit. Okay, so that will return a list under hit of all the objects, or colliders rather, that the ray hit. Okay, so if it hit an object, then it will do whatever we put inside these squiggly brackets. If it doesn't, then it won't do it. So if it hit an object, we're going to say hit.collider, which that's what it's going to hit, dot game object. Then this is going to basically, whichever collider you hit, we're going to look for a game object on that collider, and we're going to get components from that. And the component we're looking for is that script that we just wrote, which was called rotate object. Okay? And so that's inside of these triangular brackets. And then open close parenthesis, dot. And now here's where we can call that public void function that we wrote called toggle rotate. And if you've coded all this, it should pop up just like it popped up in mine if you coded it correctly. So don't forget your open close parentheses here and your open close parentheses here, and then an exclamation point. So that if it hits something, it will toggle that function and cause the moon to rotate. If it doesn't hit something else, squiggly brackets, else, hello, there we go, squiggly brackets. Then we want to do our if placement pose is valid, place object code. So grab this stuff here and cut it. Okay, and then stick it in here. So first thing, if the raycast hits an object, then we start it rotating. If it doesn't hit an object, then check if the placement pose is valid. And actually, we don't need any of this, because all we need is if placement pose is valid. That's all we need, because we've already got all this up here. We took the touch on the very first touch, and we are triggering all of this. See, this is inside of this if statement. we're triggering all of this on touch began, so we don't need that extra code. So we can just say placement pose is valid, place object. And that should be everything. Let's save it. Okay, go back to your Unity, and this should just work. Let's build. This is exciting. Okay, build settings. And build. And iOS. And I'm just going to replace. I need to check into what the difference between append and replace is. I have a feeling that I probably could just append, but I don't want to risk it right now because I know that build works, and yeah, that's just what I'm doing right now. I'm going to close my Xcode so I don't have to deal with that. And I'll check into what the difference is and when you should use append and when you should use build, and I'll let you guys know next week. Looks like I'm going to get done just before midnight. Woo! Question is, will the YouTube video actually upload and process before midnight? That's going to be tight, especially because I don't have CalArts internet to upload this super fast. Okay, there it is. And I'm going to launch this. And I have my iPad selected. I'm clicking on the top level. I am setting my signing, and I am building. All right, almost there. Build succeeded. We'll launch it then. There we go. All right. This usually makes it crash. And there it is, and I click on it. Wait. No! Okay, that was weird. Oh, I know what's wrong. I know what's wrong. Okay, so it works kind of, but I had... Alright, so it's rotating and all that. But when I'm tapping here on and trying to get it to place, I'm tapping in the middle of the screen, it doesn't work. If I tap somewhere else on the screen, it does work. And the reason why is that we're only calling that instantiate function when, I'm going to stop that, when there's not a hit with a collider. And guess what has a collider? The logo has its own collider. So let me fix that real quick. Okay. Darn it, I should have remembered that. Okay, that was another thing that took me a little while to figure out. All right, back into Unity. At least we don't have to change any scripting for this. Just go into your placement indicator, go into your quad, and here it is, the mesh collider. This is what's causing the problems, and we don't need a collider for this. It's just a graphic. So we're going to remove this component and save. And now build this. almost clicked append. I was going to risk it, but I decided not to. All right, one more time, one more build. This should do it. It was definitely rotating, so that's a good sign. So the point is, you can use this as a template and design your own scripts that you can attach to your own objects to do whatever. You can have them rotate, you can have them bounce up and down, you can use the animate function that are built into Unity and trigger a public void function that starts that animation to make like somebody walk around or dance or something like that. So it's the same method as I demonstrated here. All right, here we go. Let me close this just to make sure. Let's open that. Make sure that's selected. Click on the top level. Set my signing and upload it. Come on, let's go. 72, 100, 130, 144, 150, 164. Come on, finish your last 15 tasks. 5 tasks. Got it. All right, here we go. All right, let me launch my thing one more time, which always makes it crash. New movie recording. All right, here we go. There it is. Tap. And I can tap right on it now and it doesn't matter. And now if I tap on the moon, they rotate. Rotate. Cat's asleep. All right, so there we go. So make sure you get this working by next week. If you can't get it working, then please see Mark or see me. You can set an appointment to meet with me. I have lots of availability on Monday before 2 o'clock, on Tuesday most of the day, on Wednesday most of the day. So come see me then if you're having coding problems or you're still having problems deploying to your phone. Okay? Coolio. That was fun. Jackson signing off.